Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 27, 2026, about 5 days ago. It finds that removing prior assistant responses from conversation history often maintains response quality, while reducing cumulative context lengths by up to 10 times. The paper is titled, "Do LLMs Benefit from Their Own Words?" And as we'll see later, the results challenge a core assumption in how we design multi-turn chat systems. To illustrate this issue, Figure 1 presents a real-world example of what the authors call context pollution. On the left, in the full context setting, the model previously generated code for UMAP clustering using a Jacquard metric. When the user later asks for t-SNE, the model incorrectly carries over that old argument, which introduces a bug. However, on the right, when that previous assistant response is omitted, the model generates the t-SNE code correctly because it is not distracted by its prior output. While moving from that specific example to the aggregate data, Figure 2 quantifies this effect across 4 different models. It compares the win rates of standard full context, shown in blue, versus the assistant omitted approach, shown in red. In the left panel, where the judge sees the entire conversation history, reasoning models like DeepSeek R1 and GPT-OSS-20B show comparable performance between the two methods. However, the story changes in the right panel. Here, the judge evaluates based only on user turns to avoid bias from the assistant's previous output. Under this stricter setting, the red bars actually surpass the blue ones across the board, suggesting that omitting past responses can genuinely improve response quality. Table 1 lists specific instances of this context pollution, showing exactly how prior outputs can derail a conversation. Beyond the t-SNE bug we just discussed, the book recommendations case shows the model hallucinating titles early on and then persisting with those fake books in subsequent turns. Another clear failure appears in the model temperature example, where the assistant introduces an incorrect mathematical formula and then blindly reapplies it later. The authors even find stylistic issues, like the Python code case, where the model gets stuck in a tutorial format, ignoring new instructions to change its tone. So, having identified these issues, Figure 5 evaluates a smarter, adaptive strategy to fix them. This chart plots the response quality on the vertical axis against the average token cost on the horizontal axis. The red square on the far right represents the standard full context baseline, which performs well but uses the most memory. In contrast, the red diamond on the left shows the assistant omitted approach, which saves computation but takes a hit in performance. The sweet spot lies with the blue circles, representing the new adaptive method. These points demonstrate that by selectively filtering history, the model retains over 95% of the full context quality while cutting memory usage by nearly 30%. Alright, to visualize the sheer scale of these savings, Figure 6 plots the cumulative context length in characters over 8 turns. For models like DeepSeek R1 Distill Llama 8B, the blue full context line skyrockets to nearly 50,000 characters by the end. In contrast, the red assistant omitted line remains nearly flat, barely crossing 5,000. This gap highlights that the model's own previous outputs are the main culprit for memory consumption, inflating the context window by a factor of 10. Wrapping up, 2 key takeaways stand out. Indiscriminately retaining the model's own words is often unnecessary and can actually degrade quality via context pollution. By selectively filtering these past responses, developers can slash memory usage while maintaining performance. This suggests we should rethink standard chat designs to be far more efficient. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.